All right, Linda, our topic for today is BERT. That's a B-E-R-T, just like the name, which stands for Bidirectional Encoder Representation from Transformers. So I guess it's actually BERFT, but they went with BERT. Now, that's a very technical name, and I don't want to even get into all the technicalities with you on this show, because we're going to do a couple of episodes in a row all about BERT to wind down our natural language processing series. So what I'd like to do with you is give you a sense of why BERT is so important, why it's a big milestone, and why it's also really, really cool.
All right, let's jump in.
So BERT is a neural network that takes as input any arbitrary length of text. So it could be one sentence, could be a paragraph. That's really nice because text doesn't fit into a form very well, right? It's not like every sentence is a certain number of characters. Now you have that on Twitter, right, where there's an upper limit, but in general, text is of arbitrary length, and machine learning is not good at handling arbitrarily long things in general. So BERT is built on kind of a sequential model, but what's nice about it is its output is a fixed length vector.
I remember you brought it up in the show, but you know what? Remind me.
So depending on which version of it you choose, you get like either 768 or 128 length of a vector, which is just some numeric representation of that text. And the very surprising thing, or somewhat surprising thing, is that those numbers, which don't have any obvious meaning, are a really good way to do automated feature engineering. So they kind of prepare the text into a numeric format so that then traditional machine learning techniques can learn it very quickly.
So you're saying a fixed vector is something interpreted as numbers.
It is numbers. It's a list of numbers.
It's a list of numbers, and it allows this machine to be able to interpret it easily.
It's almost like a translation step into some secret machine language.
Yeah, okay, so it's just another way to encode something for the machine.
Yes, precisely. In a way that's very amenable to learning. It does that using a trick called masking. Now, we've talked about this before. You might remember we talked about word2vec, where I'd say, there was a sentence with a missing word, and the machine would learn to predict it based on the context.
The machine can learn it.
Like the sentence, my blank was late this week.
My blank, my train.
My check was late this week.
My bus.
My dinner was late this week.
Wow, you're all about like food and paychecks, huh? Okay.
Word2vec would do a good job guessing what fits in that blank. But now let me give you a place where Word2vec wouldn't necessarily gain any more advantage. What if the preceding parts of that were, I need to call my boss. My blank was late this week.
Well, it's probably a check.
Yeah, more likely a check, but it could be my report was late this week. My vendor was late this week. It could be lots of stuff like that. But yeah, check seems to fit very nicely.
I mean, if you guys send packages, maybe your package came late.
Oh yeah, good one. My delivery was late this week. I need to call my boss. My delivery was late this week. Yeah, so these are all very likely candidates to fit in that blank. And you and I know that from our experience with language. BERT learns kind of the same way. It looks at a massive, massive training corpus and says, what kind of patterns do I see here? And from that, it's able to kind of learn the context and what surrounding words do to help inform the middle word. And that's the same idea as Word2vec that we've had for a while. But what BERT does a little better is, through this transformer process, encode information and keep it around a little bit longer, almost as though it has a memory. So let me continue with our example here. And I'll give you two different sentences, and I'm going to ask you for candidate words at the blank, okay?
All right, I'm ready.
I am really, really worried about losing my job. I need to call my boss. My blank was late this week.
Well, at that point, I'm probably thinking it's a deliverable from that person. So probably a report or something, that whatever they're on the hook for.
Okay, here's another sentence. My company is going through some weird financial things right now. I need to call my boss. My blank was late this week.
So well, in that case, it's probably a check.
Yeah, right? So here we are 2 sentences before the blank, and there's information there you need to correctly figure out what goes in the blank.
Well, it helps. It definitely gives context.
Yeah, and that context seems to be required to solve problems like this. So BERT is leveraging a lot of the best ideas in deep learning and frameworks and techniques and that sort of thing to build up, based on a massive training set, a model that translates any text you have into an embedding. So it's a numeric representation that contains the concept and what sort of core idea is represented there, and that can then be translated back into words. Thanks to this week's sponsor, Brilliant.org. Brilliant is a problem-solving website and app with a hands-on approach and over 50 interactive courses. These courses are a mix of storytelling, code writing, interactive challenges, and problems to solve. I'm going to highlight a few for different types of listeners. If you don't already have these skills, sign up immediately for Computer Science Essentials by visiting brilliant.org/dataskeptic. There you can dive into big ideas in algorithm design. That course is designed for anyone learning computer science for the first time and programmers learning to deepen their understanding of algorithms. Now, if you'd rather just have fun, but in a challenging and intellectual way, I recommend the Puzzle Science course. It's brand new, very neat. You'll develop a solid foundation in physics while playing with puzzles. And lastly, if neither of those appeal to you, surely you'd enjoy Beautiful Geometry, where you can learn about things like the mathematics of origami. Effective learning is about problem solving, and Brilliant will help you learn and get practice. You'll come away better at problem solving. So check out brilliant.org/dataskeptic. Once more, that's brilliant.org/dataskeptic. So this all sounds like a neat idea of, hey, maybe it'd work great. Maybe this could understand language or learn patterns in language. But you got to do something empirical, right? Decide, is this actually a good framework to solve these sorts of natural language problems? So what they did with Bert was they first trained it as it was intended. They got a really huge corpus and then just trained this unsupervised embedding model that's essentially trying to predict masked words by looking at what comes before and after it and building up a layer of transformers that can hopefully capture some of the knowledge that needs to be there to represent the actual information or ideas that are there. That's what the embedding is supposed to emulate.
The embedding is supposed to emulate ideas?
Yeah, like a numeric version of an idea.
And the embedding happens on the Bert side or where?
Yeah, Bert is a model. I mean, it's an algorithm, it's all these things, but what you use it for in like a industry system or whatever is to take in raw text and get as output a fixed length vector, just numbers.
So what are those numbers useful for?
So they can be used in a variety of different ways. One way you could use them is for similarity. That vector can be thought of as a point in n-dimensional space. So just like, we picture 2D things, right? Because we can draw it. There's X and a Y, and there's points on the plot. Can you picture that?
There's an X and a Y, and then there's points. Okay.
Just typical graphs and stuff, right? Now, you can't picture, maybe you can picture 3D plots too, but I know you can't picture 4D and above. And this is in like 124 dimensional space, probably. So you can't picture it, but all the mathematics works the same. So think of it in like a two-dimensional space. I can take any piece of text and then convert it into two numbers. Now, actually, two numbers is not enough to convey all the information, but we're going to simplify it here. So you give me a sentence like, I am so mad at this company. And I convert that into the two numbers. Let's say it's 1.1x and 1.3y. And then you could take another sentence like, this is my favorite company ever. And that would convert into two numbers as well. And they would probably be kind of far apart because those ideas are different. Whereas if you converted another sentence like, I am so disappointed in this corporation, none of the words were the same as my first example, but essentially I said the same thing, right? So you would hope that it assigns, relatively speaking, the same numeric values to both of those sentences.
Right. Okay. I'm following.
The degree to which that happens, you get to take advantage of that. So you could say like cluster documents and say these are all similar. But actually, you can use this BERT stuff on an extremely wide array of tasks. So there's a classic set of problems in natural language processing like spell checking and, well, that's an easy one, but sentence disambiguation and name entity recognition and stuff like that that you might want to do against text. Most of the time, historically, people have built a specialized algorithm to try and solve those problems that really tackles that exact use case. So, for example, if you want to build a chatbot that does question answering, you would only work on question answering. You wouldn't try and make the bot so that it could also do part of speech tagging. You know what I mean?
Okay, I'm following. You got me.
All right, yeah, you build specialized tools. But with Bert, if you just take that vector, that numeric representation, and you use it as features in some machine learning exercise, Bert seems to be beating all the best known algorithms on all those generic tasks, this wide array of tasks, in fact, but it's not specialized to any of them. So it's this like much more general case tool than we've had before in natural language processing. Pretty awesome, huh?
So I'm not sure. Why is it awesome?
Because if you want to do a project in natural language processing, like make a document classifier or build a special filter for your email or something like that, to do it with machine learning, you need a huge amount of training data and a lot of compute power to train a model. Now, your own email, even though it might seem like, or feel like you get a lot of email or something like that in your life, probably in the grand scheme of things, it's not that much. It could probably fit on a small disk. So you don't have a lot of examples for training. And you can't get more, right? Unless you just want to write emails all day. So for whatever reason, a lot of problems start from having not that many examples. And that makes starting from scratch on machine learning very hard. Bert gives you like a rocket booster head start by saying, here is this unsupervised model that we've trained on general language. I think it's on the Wikipedia corpus, or maybe, and don't quote me on that, but it's on something large like that. And there are other versions of this that are coming out trained on the Reddit corpus and stuff like that, but trained on this wide, broad example of text so that we can apply transfer learning that we talked about a few weeks ago, where essentially you start from a system that has a good ability to detect the context and meaning of certain words, and then all you do is refine it for your use case. So you don't have the burden of starting from scratch and needing 100,000 documents. You can get by with maybe 100 documents because you got this head start.
Okay, so you're saying it's kind of like a shortcut.
Very much so. It's like the whistle in Mario 3.
I don't remember that. What does the whistle do again?
Jeez, Linda, it calls the tornado.
And why is a tornado good?
Because it takes you to the warp zone.
Okay.
Bert is also a little creepy in how good of a job it can do at predicting next words and, kind of writing things. I'm in short order, and we'll announce this on the show when it's ready, but going to have a demo of that you can use on our site. So not ready yet, but we'll talk about that in the future when that's checked out. So you can actually have a conversation with Bert. I don't think you will find that it passes the Turing test, but it's very interesting and almost a little bit creepy.
All right. Well, I look forward to being creeped out.
Well, Linda, have I brought you to a point where you appreciate the milestone which Bert represents?
Well, I think you definitely shed a little bit more light than I had before, so thank you.
All right.
It's like the whistle in Mario.
Well, that's a little bit blunt. That's just in terms of how it can accelerate your natural language processing project. But it's a pre-training you can extend. It takes up a heck of a lot of memory to use, but well worth it.
Awesome.
Anyway, thanks as always for joining me, Linda.
Thank you, Kyle.